Hello and welcome to this short video on multiplying and dividing fractions. So first of all here you can see we've got two mixed numbers and we've been asked to multiply them together. And with all multiplying and dividing of fractions, we really want to take any mixed numbers and write them first as improper fractions. You might also know them as top-heavy fractions. So how do we do that? Well, we take this first fraction, 1 1/3, and really the denominator here of 3 tells us we're talking about thirds, and we want to be thinking, well, how many thirds do we actually have here? 1 whole is the same as 3 thirds, and we've also got an extra third here, so 1 1/3 is the same as 4/3. Now what you might be used to doing is actually just looking at the whole number and the denominator, multiplying them together, and then adding on the numerator. That will get you to 4 thirds. And we can use the same process for that second fraction. So we're looking to multiply here by 9/4. So now we've converted these fractions into improper, we can look at multiplying them together. Now multiplying with fractions is quite straightforward in the sense that we just want to multiply the numerators together and then we want to multiply the denominators together. Now I'll show you a little shortcut for this one in just a moment, but let's deal with this first of all. If we multiply the numerators, 4 9s giving us 36, and the denominators, well, if we multiply 3 by 4 we're getting 12, and we wouldn't want to stop there because this fraction can be simplified. 36 and 12 have got a lot of factors in common, but you might notice that 36 actually does divide evenly by 12, and so 36/12 is the same as 3 12s or 36. So that's the answer to this question. I said I would show you a little shortcut, and this is going to be helpful later on, and I would always encourage you to look for this shortcut if you can. So from this stage of 4 thirds multiplied by 9/4, what it is possible to do is appreciate here that we can have some simplification going on. Hopefully you can see those two 4s. I'm just going to cross them out because they both divide by 4. This is known as diagonal cancelling, and if we divide the 4 on the numerator here by 4, it leaves a 1 behind. And if we divide this 4 on the denominator by 4, it leaves a 1 behind. So effectively we've divided the numerators by 4 and the denominators by 4. We haven't changed the overall value of this fraction, we've just simplified it a little. And we can do the same thing with the 9 and the 3 because they both divide by 3. So we can cross them out. 3 divided by 3 is 1, and 9 divided by 3 is actually 3. So it looks like a little bit of a mess just now, so I'm going to take a line just to rewrite it. We don't have 4/3 anymore, we've actually got 1/1, which is just the same as 1, and we've got 3/1. And when we do that process of multiplying the numerators together and the denominators together, we'll get 3/1. Now you wouldn't leave your answer as 3/1 because 3/1 simplifies to 3. Now you might think, why bother with all of this cancelling here when I can just simplify at the end? And of course it's absolutely fine to simplify at the end, but sometimes the numbers can be a little bit bigger, a little bit unpleasant. So if there's some diagonal cancelling like we saw here, then I would recommend that you try and simplify as early as you can. Now I said we would do some dividing as well, so here we go. And in the same way as multiplying with fractions, we want to take these mixed numbers and write them first of all as improper fractions. And so one way of doing that is multiply the whole number by the denominator. In this case that gives 20. Add on the numerator to give us 24/5. So 24/5 there is the same as 4 4/5. And don't forget we're dividing this time by 27/10. So nothing on that first stage other than just convert both the mixed numbers into improper fractions. Now, nobody really wants to divide by a fraction. What we can do to make our life a bit easier is instead of dividing by a fraction, we can multiply by what's known as its reciprocal, which essentially takes that second fraction and swaps the numerator and the denominator around. So what we're doing now is changing our divide into a multiply, but multiplying by the reciprocal of that second fraction. And here again, if you can see it, there's a little bit of cancellation allowed, and we can cancel out the 10 and the 5. They both divide by 5. That would leave a 1 behind where the 5 was and a 2 where the 10 was. And the 24 and the 7, they also divide by 3, so that leaves us with 8 and a 9 on the bottom. So what we've really got now is 8 over 1 multiplied by 2 over 9, and we can do that multiplication to get ourselves toward the answer. 8 over 1 multiplied by 2 over 9, that gives us 16 over 9. Now, that is an answer, but it's not quite finished because it can be written as a mixed number. We want to ask ourselves how many 9s are in 16? Well, the answer is 1. And what's left over? Well, there's 7 9s left over. And you might find the questions specify that you have to leave your answer as a mixed number, but if it comes as a mixed number in the question, then it's a good habit to get into of returning it to a mixed number in the end.